Hello, my name is Hannah Sullivan and welcome to my video on determining the direction of the induced current from a changing magnetic flux. And so currents can be induced from a changing magnetic field, meaning a changing magnetic flux, as I've already stated. And this can be from a rotating coil, a moving or an alternating magnetic field, and or from the coil moving along the plane that it's situated in. And flux is important because it is the change in flux that induces voltage and current, and that determines the current's direction. And we can see this with our equation: negative voltage induced is equal to negative current induced times the resistance is equal to the time derivative of the magnetic flux. And so we're going to determine the current induced direction by pointing our thumb in the direction that the dA vector of our loop points in. And then we're going to determine the change in flux. And then we're going to, depending on that value for the change in flux, switch our thumb or keep it in the same direction according with the equation that we just went over. And then we're going to curl our fingers, and that will be the direction that the current induced will go. So we have an example here that asks for the current induced if there is one, and to state the direction. So we have a ring connected to a battery with a B field produced that is going in the positive X direction, and a second ring that ends up falling face first. And so for the sake of time, I've already written in and determined the direction of the dA vectors. In the initial situation, it is going in the positive X direction. And so that means that we have a positive flux. And so in the final flux, when the ring falls over, the dA vector is now in the negative Y direction, and so it is now perpendicular to our B field in the positive X direction, and that means that our final flux is 0. So the change in flux is negative. So in accordance with our equation, that means that voltage induced is positive, and now our current will be going in the counterclockwise direction in this ring. Thank you for watching my video. I hope that was helpful.